Okay, in the last video, we were going to use this triangle here to express theta in terms of the variable z. And that is because we want to solve this integral and get it expressed in terms of z, not theta. Then when we do that, we want to make this substitution here so we can have the solution to our original integral. So let's proceed. This will equal 2a divided by b squared times the tangent squared of theta. So that would be z squared divided by a. Then we have plus 4a over b squared times the natural log of the cosine of theta. That's the side adjacent divided by this. So it'd be the square root, this divided by this, or we could say a divided by z squared plus a to the 1/2 power. And of course, we'll have a constant of integration. So this now is the solution to this integral right here. So let's make some room. And we'll rewrite this up here. Okay, this integral here equals this. So we're going to write this up here now. 2a times z squared divided by b squared a plus 4a over b squared, the natural log of a over z squared plus a. To the 1/2 power. Okay, let's see. It looks like these a's here are going to cancel out. So we have 2 over b squared, 2 over b squared times z squared, and that's b times the square root of x. So we have b times the square root of x plus 4a over b squared. And matter of fact, let's use the property of logarithms. 1/2 times 4, that would be 2a. The natural log of a divided by z squared plus a. So that will be a plus b times the square root of x plus a constant. So now that we have z expressed in terms of the variable x, this here should be the solution to this integral. And it looks like these b's here are going to cancel out, so we'll just have 2 over b times the square root of x minus 2a over b squared times the natural log of a divided by a plus the square root of bx plus c. And because of the property of logarithms, and because of the fact that this is an arbitrary constant, we might be able to simplify this. If this was in the bottom here, then we have the natural log of this minus the natural log of a, which is a constant, and here we have a constant. So, let's see, we could say this equals, this stays unchanged, 2 over b times the square root of x, and plus 2a over b squared, the natural log of a plus b times the cubed square root of x divided by a to the minus 1 power plus c. This to the minus 1 is this, and now we can use the property of logarithms. This would be minus 2, and the minus 1 from here goes away, and now this will equal 2 over b times the square root of x minus the natural log of, now we're going to have the natural log of this minus the natural log of the denominator here. We have a minus sign out here, so this would be minus 2a over b squared, the natural log of this, a plus b times the square root of x, minus this, with a minus sign, that will be plus 2a over b squared, the natural log of a plus c. And this is a constant. This is an arbitrary constant, so we can combine these together into another arbitrary constant. We'll call it a. So then finally we can say, alright, the integral of dx divided by a plus b times the square root of x equals this, 2 over b times the square root of x minus 2a over b squared, the natural log of a plus b times the square root of x plus a constant. So this certainly is an acceptable answer. We have just simplified a little bit down here by taking advantage of logarithms along the way. Okay, that's it for this video. Come back and join us for some more videos, and we'll see if we can solve some more integral problems that have these, that incorporate these radical expressions.